Welcome back, everybody. Today, we're going deep on Chapter 6 of Service-Oriented Architecture, Analysis and Design for Services and Microservices.
We're very exciting.
We're going to unpack, how to model systems using, all these new and wonderful things, web services and microservices.
Yeah.
So you ready to get into it?
I'm ready. I'm ready to dive deep.
Awesome. So this chapter, it really is a goldmine if you want to understand how to take, these big, huge business processes and turn them into something that's really elegant and, beautiful software.
Right.
So, you're not just building this giant clunky application to do everything.
No, it's like, imagine building a house, right? You wouldn't just start laying bricks without a plan.
Right.
You'd have blueprints that detail each room, the plumbing, the electrical systems. And that's what this chapter gives us, a blueprint for building software.
Okay. I'm starting to see the light here.
Yeah.
And the chapter lays out a 12-step process for modeling web services. What are some of the key steps we should be paying attention to here?
Well, the first step is always to decompose the business process.
Okay.
So this is where we take that big, complex process and break it down into smaller, more manageable actions.
Got it.
So, for example, imagine we're building a system for a transportation company, right? Like, let's say Transit Line Systems, Inc. They have this process for managing their fleet of vehicles, which involves things like scheduling maintenance, dispatching drivers, planning routes, and so on.
Right. And I'm guessing they don't want one massive program try to handle all that at once.
Yeah, exactly. So we'd break that process down into individual steps.
Okay.
So we would say, schedule maintenance, dispatch driver, plan route, right?
Right.
And each of these steps then becomes a potential candidate for a service.
Okay, so we're creating smaller, specialized pieces of software that each handle a specific part of the process.
Yeah.
But how do we even know which actions are even suitable to become a service?
Right. That's where step 2 comes in.
Yeah.
Filtering out unsuitable actions, because not everything, can or should be automated.
Yeah.
Some tasks, they might require human judgment, creativity, or empathy,
Yeah.
which are things that are really difficult to program into software.
Right.
Or it might just not be cost effective to automate certain tasks. So it's about being strategic and focusing on the areas where automation can really make a difference.
Right. It's like choosing your battles, kind of.
Exactly, yeah. And then as we go through the remaining steps, we start to identify those even smaller independent units of functionality that can be developed and deployed separately.
Okay.
And we call those microservices.
So microservices are like the building blocks of our system.
You got it. Think of them like Lego bricks.
Lego bricks? Okay.
You can combine them in countless ways to create all sorts of structures.
Oh, okay, that's a helpful image.
Yeah.
But Legos can get messy if you're not careful. How do we make sure all of these microservices work together seamlessly?
Right. And that's where the later steps in the process come in.
Okay.
We look at how the different services will communicate with each other, what data they need to share, and how we can ensure that the overall system is resilient.
Resilient.
And scalable.
Okay. Break those down for me. What do you mean by resilient and scalable?
Sure. So a resilient system is one that can handle failures gracefully. So let's say, one microservice goes down. In a poorly designed system, that could bring down the entire application.
Oh, wow.
Right. But in a resilient system, other services can pick up the slack or reroute requests so that the overall system keeps working.
That's amazing.
Yeah.
So it's like having backup generators for your software.
Exactly. Yeah. And then scalability. Scalability means that the system can handle increased demand without falling apart.
Okay.
So, let's say our transportation company, suddenly gets a huge influx of new customers.
Okay. Yeah.
A scalable system can easily add more computing resources to handle that extra load, ensuring smooth operation even during peak times.
This is all starting to make sense. So we're not just building software. We're designing a system that's flexible, adaptable, and can grow and evolve over time.
That's the beauty of service-oriented architecture. And Chapter 6 gives us the blueprint for making it happen.
This is incredible. We've talked about breaking down business processes. We've talked about identifying services and microservices and building systems that are resilient, scalable.
Right.
What else does Chapter 6 have in store for us?
Well, one of the most important aspects of service-oriented architecture is something called loose coupling.
Loose coupling.
Loose coupling. This means that the different services in our system are independent of each other. They don't need to know the inner workings of other services. They just need to agree on how to communicate.
So it's like each service is speaking its own language, but they have a translator that allows them to understand each other.
Yeah, that's a great way to put it. And the reason loose coupling is so important is because it makes our system much more flexible and adaptable.
I can see how that would be helpful.
Yeah.
But why is that so important? Like, why is that flexibility so important?
Well, think about it like a chain reaction. If services are tightly coupled, a problem in one can bring down the entire system.
Oh, okay.
Like dominoes falling, one after another. Loose coupling acts like a firewall, preventing those domino effects.
Oh, that's a powerful image.
Yeah.
So loose coupling helps to prevent, like, catastrophic failures.
Right.
Makes our system more reliable. I'm starting to see why this is such a big deal.
Yeah, it really is. And it goes hand in hand with the idea of modularity, which we've already kind of touched on.
Okay.
Each microservice is like a self-contained module that can be developed, tested, and deployed independently.
So if we need to make changes to one part of the system, we don't have to rebuild the entire thing.
Exactly. We can just focus on the module that needs to be updated without affecting the rest of the system.
Okay.
And this makes development and maintenance much more efficient. And it reduces the risk of introducing new bugs.
This is all making so much sense. We've covered a lot of ground already, from breaking down business processes to the importance of loose coupling, modularity.
Yeah.
What else should we be thinking about as we delve deeper into this chapter?
Well, there's one more concept I think is crucial to understand, and that's the idea of reusable versus single-purpose logic.
Okay, bring that down for me. What do you mean by reusable logic?
So think of it like this. Let's say our transportation company needs to calculate the distance between 2 points. We could write a specific piece of code for that purpose, just for that one use case.
Okay.
That would be single-purpose logic.
Right.
But we could also write a more generic piece of code that can calculate the distance between any 2 points, regardless of the context.
Oh.
That would be reusable logic.
So reusable logic is like a multi-tool that we can use for various tasks, while single-purpose logic is more like a specialized tool designed for one specific job.
Exactly.
Yeah.
And the choice between the two depends on the specific needs of our system. Sometimes, you need that specialized tool to get the job done right.
Right.
Other times, the flexibility of the multi-tool is exactly what you need.
I see. So it's about finding the right balance between reusability and, specificity, depending on the task at hand.
Precisely. And that's one of the key decisions we need to make as we're designing our system.
This is all incredibly insightful. I'm already feeling more confident about navigating the complexities of service-oriented architecture.
That's great to hear. And remember, we're just getting started. There's so much more to explore within this world of building adaptable, scalable, and efficient software systems.
I can't wait to dive deeper. But for now, let's wheeze. Welcome back to our deep dive into Chapter 6. We've been laying the groundwork, but now I'm kind of itching to see how all of this stuff plays out in a real-world scenario. You mentioned Transit Line Systems, Inc. earlier. Could we, dig into how they actually apply this whole web service modeling process?
Oh, absolutely. Remember, they were facing, the classic challenges, siloed systems, inefficient processes, and struggling to keep up with change. So they decided to embrace service-oriented architecture to try to overcome these hurdles.
So they were trying to, manage this whole fleet of vehicles with a bunch of disconnected systems. I bet that was causing some major headaches.
Oh, you bet. Imagine trying to, track maintenance schedules, plan routes, dispatch drivers, all with these separate programs that couldn't talk to each other. It was a logistical nightmare. And that's where the web service modeling process really came to the rescue.
Okay, so walk me through how they used this 12-step process. Did they actually sit down and meticulously follow each step?
They did, and it really helped them transform their fleet management system into something much more streamlined and flexible.
Wow.
So they started by dissecting their existing processes, just like we talked about, right? They identified all the key activities involved in managing their fleet, from scheduling vehicle maintenance to, optimizing routes based on real-time traffic conditions.
So taking those big, messy processes and breaking them down into smaller, more manageable chunks, right?
Precisely. And as they went through the steps, they started to see which of those chunks could be turned into independent services. For instance, they realized they could have a vehicle maintenance service, right? That keeps track of all the repair records, schedules upcoming maintenance tasks, and even, alerts mechanics when a vehicle needs attention.
Ah, so instead of having maintenance information scattered across different systems, it's all centralized in one place. That's got to be so much more efficient.
Exactly. And here's where it gets really cool, right? Remember we talked about reusable logic?
Yeah.
Well, TLS realized that this vehicle maintenance service could actually be used by other parts of their system.
Hold on. Give me an example. How could they reuse something as specific as vehicle maintenance?
Okay, so let's say their route planning service, right?
Yeah.
Wants to avoid assigning a vehicle that's due for maintenance to a long trip. It can simply tap into the vehicle maintenance service to check the vehicle's status before, finalizing the route.
Wow, so the systems are actually communicating with each other and sharing information like behind the scenes. That's way more sophisticated than their old setup.
Right. And that's the power of loose coupling in action. You see, the route planning service, it doesn't need to know the intricate details of how the vehicle maintenance service works. It just needs to know how to ask her the information it needs.
So it's like they've established a common language that allows different parts of the system to talk to each other, even though they were built separately. That's pretty slick.
It is, and it makes the whole system much more adaptable. Imagine they decide to implement a new routing algorithm, right?
Okay.
That takes fuel efficiency into account.
Yeah.
They can just update the route planning service without having to touch the vehicle maintenance service at all.
So they're not stuck with a rigid system that's hard to change. They can evolve and adapt as their needs change.
Exactly. And that's what service-oriented architecture is all about. Creating systems that are agile, resilient, and aligned with the ever-changing demands of the business.
This is all starting to click for me, but we've been focusing so much on web services. Didn't the chapter also mention something about REST services?
Yes.
How do those fit into the picture?
They're kind of like a close cousin of web services, but with a slightly different approach. Remember how we talked about building software that's loosely coupled and modular? Well, REST services take that to another level. They leverage the very architecture of the web itself to create services that are simple yet incredibly powerful.
Wait, the architecture of the web, you mean like websites and URLs and stuff?
You got it. Think about how you interact with a website, right? You type in a URL, which points to a specific resource, and then you use verbs like get to retrieve information or post to submit data.
Okay, so it's kind of like we're using the web's language to build our services.
Exactly. And that's what makes REST so elegant and efficient. It leverages existing web standards, so there's no need to reinvent the wheel. Plus, it naturally encourages a loosely coupled architecture, which, as we've already discussed, is crucial for building adaptable and resilient systems.
This is starting to sound pretty fascinating. Can you give me like a concrete example of how REST services could be used in KLS's fleet management system?
Sure. Imagine they want to expose information about their vehicles to other systems, maybe like a third-party app that helps drivers find the nearest available vehicle.
So they want to make that data accessible to the outside world, not just within their own system.
Right. With REST, they could create a vehicle resource, and each vehicle would have its own unique URL, kind of like a web page, right?
Okay.
And other systems could then use standard HTTP verbs to interact with that resource.
Hold on, give me an example. What would that look like in practice?
Okay, so let's say the third-party app wants to display the current location of a specific vehicle. It could send a GE2 request to the URL associated with that vehicle, and TLS's system would respond with the vehicle's GPS coordinates.
So it's like asking the system, hey, where's this vehicle right now? And getting a real-time update. That's pretty cool.
It is. And because it's all based on web standards, it's incredibly easy to integrate with other systems, even those that were built using different technologies.
This is all starting to make a lot of sense, but we've thrown a lot of information at our listeners today.
Yeah.
Before we move on, can we take a moment to just recap the key differences between web services and REST services?
Absolutely. Web services are like a more general approach to building interconnected systems. They can use various protocols and data formats, and they're often used in enterprise environments where security and reliability are paramount. REST services, on the other hand, are specifically designed to leverage the simplicity and power of the web. They're all about using URLs to represent resources and HTTP verbs to interact with those resources.
So REST is like a more streamlined and web-centric approach to service-oriented architecture.
Precisely. And it's gaining immense popularity because it's so easy to use and integrate with other systems.
This has been incredibly insightful. We've gone from, dissecting business processes to exploring like the nuances of web services and REST services. I feel like I have a much better grasp of, how to approach building these flexible and adaptable software systems.
That's fantastic to hear. And remember, we've just scratched the surface. There's a whole world of like techniques and best practices for designing and implementing service-oriented architectures.
I'm eager to dive deeper. But for now, let's give our listeners a moment to process all this information. We'll be back soon for the final part of our deep dive into Chapter 6.
Welcome back, deep divers. It feels like we've covered a ton of ground in our exploration of Chapter 6, from the nitty-gritty of that whole web service modeling process to real-world examples like transit line systems, Ink, and even a glimpse into REST. My brain is definitely full.
It's been quite a journey through service-oriented architecture, hasn't it?
It really has.
We've seen how powerful it can be for building software that's, not only efficient, but also adaptable and resilient.
Yeah, and before we wrap up this deep dive, I was thinking back to something you said earlier about the potential downsides of reusable logic, and you mentioned something about over-engineering, and I have to admit that part made me a little nervous.
Yeah, that's a great point, and it's a common trap that a lot of developers fall into, right?
Right.
It's so tempting to try to make everything reusable, thinking we're creating this amazing toolbox of code that can be used for any situation.
But sometimes that can actually make our systems more complex and harder to maintain.
So it's kind of like having a Swiss Army knife with so many attachments that you can't even figure out how to open the main blade.
Exactly. If we're not careful, we can end up with services that are too generic, trying to do too many things at once, and ultimately becoming less efficient.
So how do we avoid falling into that trap? Is there like a way to know when reusability goes too far?
It's all about striking the right balance. As we're designing our system, we need to constantly be asking ourselves, is this functionality truly likely to be reused in other contexts, or am I just trying to be clever? Sometimes a simple, purpose-built solution is the best approach, even if it means sacrificing some potential for reuse.
So it's about being pragmatic and choosing the right tool for the job, rather than trying to create like a one-size-fits-all solution for everything.
Exactly. And that's where experience and good judgment come into play, right? As we become more familiar with service-oriented architecture, we develop a better sense of when to prioritize reusability and when to keep things simple and focused.
This whole conversation has really highlighted the importance of careful planning and design in software development. It's not just about writing code. It's about thinking strategically about, how different parts of the system will interact, how they'll scale, how they'll handle failures, how they'll adapt to change.
You've hit the nail on the head. Service-oriented architecture forces us to think about software in a more holistic way, considering not just the individual components, but also the bigger picture of how they all work together.
It's like we're not just building a house, we're designing a whole city with different districts, transportation systems, utilities that all need to function seamlessly.
I love that analogy. And just like a city planner has to consider, the needs of the residents, traffic flow, future growth, we as software architects need to think about, the users of our system, the flow of data, the long-term evolution of the application.
This has been an incredibly insightful deep dive. We've learned about breaking down complex processes into manageable services, the power of loose coupling and modularity, the nuances of web services versus REST services, and the importance of finding that sweet spot between reusability and simplicity. What are some key takeaways you want our listeners to walk away with?
I think the most important takeaway is that service-oriented architecture is not just a set of technologies or tools, it's a mindset. It's a way of thinking about software design that empowers us to build systems that are truly adaptable, scalable, and resilient.
And it's clear that this approach can be applied to a wide range of industries and problems, from managing a fleet of vehicles to processing financial transactions to delivering personalized online experiences.
Absolutely. The principles we've discussed today are applicable to almost any domain where software is used to solve complex problems.
Well, this deep dive has given us a solid foundation for understanding service-oriented architecture. But for our listeners who are eager to learn more, perhaps even start applying these principles in their own work, what would you say to them?
I'd encourage them to, keep exploring. There are countless resources available online, books, articles, tutorials, and of course, they can always revisit Chapter 6 of Service-Oriented Architecture, Analysis and Design for Services and Microservices for a deep dive into the topics we've touched on today.
That's great advice, and I think it's important to remember that this is a journey, not a destination. There's always more to learn, new technologies emerging, best practices evolving.
You're absolutely right. The world of software development is constantly changing, and the best we can do is to embrace that change, keep learning, and always be striving to build better, more efficient, and more adaptable systems.
Will said. And on that note, I think it's time for us to resurface from this deep dive. A huge thank you to our listeners for joining us on this exploration of service-oriented architecture.
Until next time, keep those minds curious and those codes clean.